So what we have here is how we can do prediction with the current networks when the output is also a sequence. And so this is the typical scenario would be for translation from one language to another. And so what I'm showing here is a figure from the paper by Satskever and colleagues from 2014, so from the very beginning of the revival of interest in deep learning. And it was called sequence-to-sequence learning with neural networks. And so they showed a simple scheme of how to make LSTM output read a sequence and output another sequence. What they did, they simply concatenated the two sequences together, and you can see that they reversed the second one. They predict the second one in reverse because that meant that the dependencies were in general shorter. Because what is happening here is that you will, well, what you will see that not so much that on average the dependencies would be shorter, but rather some of the dependencies would be shorter, right? So in the general case, in translation, even though there is some reordering, in general, things that are at the end of the sentence in one language would also tend to be at the end of the sentence in another language. So if you reverse the second sequence, then the end of the first sentence would be close together to the end of the second sentence, as you can see here with the letters C and W. And so they did this, and so they concatenated these two sentences, and then they had the LSTM predict the output sequence while inputting the previous what should have been output at the previous time step. Okay, so you can see here that there is this when they start predicting, there is the symbol EOS standing for end of sentence, and at that point in time the network is supposed to be predicting W. At the next point in time the network is seeing the input W, so corresponding to what should have been predicted at the previous time step, and is predicting, it should be now predicting X, and so on. So this was a very simple architecture, basically just a plain LSTM, just with a little bit of creative arrangement of the data. There are now machine learning now typically, machine translation is typically now done with different architectures, but this already worked reasonably well and was very simple conceptually, at least compared to approaches to machine translations which were at that time popular, which were very complex to engineer.